Hello everyone, myself Ganga Deepakumar, pursuing third year CSC in Sri Venkateswara College of Engineering, Kadapa. First of all, I would like to thank Emertxe Group for providing free internship to the students, and our project guide is Jayalakshmi ma'am. She helped a lot in developing various projects. Coming to slide 2, we have contents. Concept during learned during internship: C programming, IoT, embedded systems, microcontrollers. Coming to the project, I have learned overview, objective, design elements, simulation, conclusion. Coming to topic IoT, as of all know what is IoT. IoT is describing physical objects with sensors, processing ability, software, and other technologies that connect and exchange data with other devices and systems over internet or other communication network. In slide 4, we have about C programming. As of everyone know, it is a general purpose language, even though it is applied and used effectively in various specific domains. Topic learned in C are data types, modifier and qualifier, conditional and loops, operators, array and pointers, string, functions, storage classes, preprocessor. In Internet of Things, we have various applications used mostly in healthcare, automobile, logistic and transport, and in business also. Example: wearable health monitors, smart cars, smart buildings, home automation. Embedded systems. An embedded system is a combination of computer hardware and software designed for a specific function. Embedded systems use the communication port to transmit data between the processor and peripheral devices, often other embedded systems using a communication protocol. Generally, they comprise of a processor, power supply, memory, and communication ports. Embedded systems. Embedded systems are mostly used in CAD scanners, implanted heart monitors, electric vehicles, household appliances. Microcontrollers. Microcontrollers are used in ADC block and DAC block. Microcontrollers used in timers and counters. Microcontrollers is also used in processors, memory and input or output ports. Microprocessor versus microcontroller. Microcontroller is used in RAM, ROM and its types. Project overview. This project provides IoT based home automation solutions using Arduino UNO board in PiximLab simulator. To remotely control the device, we use an app named Blink IoT. We automated the garden lights where they brighten according to sunlight. Temperature control system is automated. Last and not least, the water tank is automated by controlling the inlet and outlet valve respectively. Coming to project objective, connect all the discussed home appliances to Arduino and integrate it with Blink app and cloud. Obtain critical notifications regarding temperature and water tank on the Blink IoT app. Check the real-time status of temperature and water level on the Blink IoT app to control the garden lights automatically. Need for home automation. If we focus on our daily life schedules, there are many devices which are monitored as we move to office, colleges and other places. First, to avoid such negligence and also to protect our houses from many incidents, we can use automation. We can control many home devices using automation. Few of them are covered in this project. Arduino UNO. Arduino UNO is a microcontroller board based on a T-Mega 328P. It has a 14 digital input or output pins. 6 can be used as a PWM output, 6 analog input or output pins, a 16 MHz ceramic resonator, a USB connection, a power jack, an IC/SP header and a reset button. Arduino UNO board can be programmed using various IDEs. We used Arduino IDE for this project. PiximLab and Blink IoT app. Fixing Lab is an open source real-time accumulator of development boards with integrated MP LaTeX. It has integration with Arduino IDE for programming the board's microcontroller. Blink is an IoT platform for iOS or Android smartphones that is used to control Arduino via internet. We understood how to create new templates, how to add a new device, how to add and select data stream, how to create icon and include Blink library. LDR means light dependent resistor. These light dependent resistors are tiny light sensing devices, also known as photoresistors. And LDR is a resistor whose resistance changes as the amount of light falling on it changes. Temperature control system. Temperature control system consisting of healing resistors and LM35 temperature sensor and a cooler. Analog value of temperature is obtained from the temperature sensor LM35 and display it on CLCD after converting it into digital value using ADC. Water inlet and outlet valve control. Read the volume of the water in the tank through serial communication and display it on the CLCD. Control the volume of the water in the tank by controlling the inlet and outlet valve by sending commands through serial communication. Display the volume of water in the tank on the CLCD and also on Blink IoT app. The main features is that as soon as the tank is full, the inlet valve is turned off. And when the water level in the tank is below 2000, the inlet valve is turned on automatically and the notification for the same is provided on the terminal on Blink app. Simulation image. As you can see in a simulation image, this simulation image is only meant for showing of the image like a temperature, cooler, heater, how the tank is filling, how the tank is losing the water in tank. Temperature sensor. The temperature is recorded using a LM35 sensor which reads analog values. The value is converted into binary value and the actual temperature is calculated using the obtained value of voltage. The sensor doesn't require any external calibration to provide accuracies in result. Garden light control. As everyone know, garden light control is works on the sunlight. As during the day, outdoor light is maximum, so the LDR sensor detects the light and the garden light is turned off. Whereas at the night, the outdoor light is very low, so the LDR sensor detects the light and the light is turned on. Conclusion. Using Blink IoT application and PixSim simulator, we simulated home automation where LED temperature serial tank resembles light, heater, cooler and water tank in real time. CLCD acts like a dashboard used for displaying the events. Widgets from a Blink IoT app like button widgets are used to control heater, cooler and inlet valve and outlet valve. Gauge widgets to display the temperature and volume of the water. And the project provides perfect solution for home automation. Home automation using Blink. In this home automation, we are going to use some sort of peripherals like Arduino Uno temperature system. We are going to use LED, LDR model, and we are going to use serial tank also, Blink app. Here we are going to use some sort of Blink libraries like SPI.h, Ethernet.h, and Y.h, Liquid Crystal I2C.h. Liquid Crystal I2C set the LCD address to 0 to 27 for a 16 characters and 2-line display. This function is called every time the virtual pin 0 state changes. Blink write cooler V pin to read the values on the virtual pin connected to the cooler. If we on cooler, it will print cooler on. Else, if you off the cooler button, it will print cooler off. To turn on and off heater based virtual pin value and print notification on the CLCD. When we on the heater, it will print the heater is on, or else if we off the heater, it will print the heater is off. in blink inlet out in inlet. If we on inlet button, the tank is filled. If we off the inlet button, nothing happens. It will the tank will be in same position. To turn on off on inlet value based virtual pin value, by using a blink right inlet V pin. To read the values on the inlet pin, the if enable inlet inlet print LED on, inflow on, else it disables inlet. If you disable inlet, it will print inflow off. To turn on and off outlet value based virtual switch value, blink underscore right outlet V underscore pin. To read the values on the outlet pin, outlet SW equal to rm dot as int. If we enable outlet, it will print outlet on, or else if we disable outlet, it will show or print outlet off. To display temperature and water volume as gauge on the blink app, void update temperature reading is used. You can't send any value at any time. Please don't send more than 10 values per second. To turn off the heater, if the temperature rises above 35 degrees Celsius, to handle temperature, leave temperature and compare with 35 and also check if the heater is on. Heater turn off the heater. It will show that heater is off. To print the heater status on the dashboard, it will print heater off or else on. To print the notification on the blink app, by using virtual right, to reflect on the button widget on the heater pin, blink virtual right heater V pin is used. To control water volume above 2000 liters, void handle tank is used. If to check if the volume of water is less than 2000 liters and inlet valve is off, the enable the inlet value if tank volume less than greater than 2000 less than 2000, enable inlet. To turn off notification on the dashboard, LCD set cursor and LCD print inflow is on. To print the notification in the mobile app, blink virtual right is used. Volume of water is less than 2000 liters, turning on the inlet valve. If the tank is full and the inlet valve is on, then turn off the inlet valve. Tank volume equal to 3000 equal to 3000. To print if the tank is full, turning off the inlet valve, reflecting the status on the button widget. To configure the garden lights as output, init LDR is used. Initializes the CLCD. LCD initial is used. LCD backlight is also used for the sensing of lights. To set the cursor to the first position, LCD.home to see the sting, LCD.set cursor, LCD.print to set the cursor at second line position. To connect Arduino to the blink cloud, blink.begin arch is used. To initialize temperature system is used. To initialize the serial tank, serial tank is used. To update the temperature to blink app for every 5 seconds, timer is set set interval with the function by void loop blink to read the temperature and display on the CLCD. Sting temperature is used. Temperature equal to string read temperature is also used to read volume of water and display it on the LCD. CLCD, tank volume equal to volume. We are going to set the maintain the volume of water 2000 liters to maintain to maintain or handle the tank to threshold temperature. And next we are going to idr.h and arduino.h and some main.h. In this brightness control, to read the values from the IDR sensor connected to A0 pin. For reading the analog pin, we are using the function analog.read. Mapping 0 to 1023 greater than 255 to 0. Scaling down 0 to 1023 greater than 255 to 0. So assign a duty cycle LED based LDR valve analog right garden light is used. In idea.h we are going to see we are going to define or use the sensor LDR sensor to A1 and garden light 3. Void brightness control void. In main.h we are going to define a temperature gauge, cooler, heater, water inlet, outlet, blink terminal, V pin, and we are going to temperature gauge V1, cooler and for V0, heater is V2, water is V3, inlet is V4, outlet is V5, blink terminal is V6. Then serial tank and to begin the serial communication between serial tank and Arduino board, serial.begin is used. Serial write is used for synchronized communication. Serial write unsigned int volume void to read the volume of water. While serial not available, reading the higher byte, reading lower byte, and so on. Combining higher byte and lower byte is used to is called volume value equal to value less than equal to 8 and so on, some sort of value. To return the value, to return the volume of water, return volume underscore value. For enabling inlet, serial dot write inlet valve enable is used. Void disable inlet is used in for disabling the inlet. Void enable outlet is enabled. Outlet is enabled. Void disable outlet void serial dot write outlet underscore value serial dot write underscore disable. Serial tank underscore h for reading this input digital. This is mainly used for input digital signals, inlet valve, outlet valve, and some sort of sensors and some sort of unlocks is used. In sensors we use high float, low float. In sensor we use like volume, enable, disable, and so on. Temperature in a temperature system we use how the temperature is working, how the cooler is going to decrease the temperature to continue to configure heater and cooler pins as output. To read the analog values and converting into voltage and then to voltage into temperature in degrees Celsius by using analog read function to control the cooler. Void control is used. If cooler is high, then cooler is on. If the cooler is off, low, the cooler is off. If the heater is high, the heater is on. If the cooler is low, the heater is off. In temperature system, we are going to define heater and the cooler, and the temperature sensor A naught. Now we are going to the Pixim lab. Here, here in the image you can see, we can see the display, which is made up of CLCD used for displaying, and you can see LDR sensing in the below, and in above we can use the heater, cooler, and so on. This mainly this LDR is used for sensing the sunlight outside the surroundings and so on. This showing in the image is Ethernet, which is connected to the Arduino board. This as you can see, the red light mentioning above is used for signaling. That means it indicates the signaling. You can see the rightmost side, we have one circle type one, which is used as a heater, cooler, temperature, and so on. Now we are going to the serial tank, which is present. If we on inlet, the water tank is filled, and if we off also, nothing happens. When we turn on the outlet, and when we turn an outlet, it will decrease. It will the tank size will going to be decreased. If it reaches to 2000 liters, we have to stop the outlet, and we have to on the inlet, so that it will going to be filled again, so that the tank will be filled. Now we are going to see how it is going to execute it. Wait for the few seconds. Wait for a few more seconds. Yeah, you can now now you can see the blink app, which is present on my screen. Now we are going to open this app, and please look at what is going to happen. Now we are opening. Now we are going to see what is going on if we switch on, if we switch off the blink app. Now we are going to Pixim lab, and we are going to see the what is going to happen. Now you can see I am switching on the cooler. Wait a second. Wait for a few more seconds. In this, you can see the screen the is present in my laptop. If we switch on, if we switch on cooler. Yeah, you can see in the image it is rotating. And if we switch off, then the cooler is going to stop. If we switch on the heater, yeah, you can see in the CLCD image the temperature is increasing. If it reaches to 35 degrees, it is going to stop, and you can see the notification in the temperature is above 35 degrees Celsius. Temperature is above 35 degrees Celsius. Turning off the heater. Turn off the heater. If the cooler is on, then the temperature is going to decrease. If it reaches to 27 degrees Celsius, it is going to stop. Coming to the tab 2, we have inlet and outlet. If you on inlet, the tank is going to be filled. If you turn on outlet, you can see the tank is going to be decreased, and the volume is also going to be decreased. If the volume decrease to 2000, it will stop, and in the inlet value automatically turn on, and the tank is going to be filled. If the volume of water is less than 2000 liters, turning on the inlet valve, tank is full, Turning off the inlet valve, turning off the inlet valve. Yeah, thank you. This is about inlet and outlet. And coming to Pixim lab, you can see the LDR sensor for sensing if the outside surroundings is so maximum, the light doesn't blink. If the surroundings are if the sunlight is high, the light doesn't blink. If the sunlight is minimum at the outside, the light is going to blink. Automatically is going to blink. And now I am going to show how it is working. I can see if it is maximum, the light falls. It automatically blinks the light. If we reduce, the light is going to be off. Thank you for giving this opportunity.